In this video, we're going to look at some supplemental review questions for test number 4. Also, here at the beginning on this first page, I have provided a list of formulas that you may want to write down and have available as you're taking test number 4. One of those is the change of base formula for a logarithm. Our calculators only allow us to calculate if we have a base of 10, which is represented by log, L-O-G, or if we have a base of e, the natural number, which is represented by ln. Those are the only two buttons on our calculator. So if you have some odd base, like a 2 or a 3 or a 7, then you have to use this formula to do the calculations in your calculator. I've provided you the compound interest formula, the continuous compounding interest formula, which is also used in radioactive decay problems, and then the formula for if you want to make monthly payments or deposits on a particular account. So those are available. I do not believe they're provided on test number 4. So again, you may want to write those down and have them close by as you are taking test 4. So the first question, which I didn't see one like on your review sheet, asks you to evaluate log base 8 of 2. So it's really asking you that value. And so if we look at this from the perspective of the change of base, I would want to use the change of base here because I can't put log base 8 into my calculator directly. I would have log of b of a. So the b is 8 and the a is 2. So using that formula in terms of what I need to put into the calculator, I need to put log of 2 divided by log of 8. Okay, so I'm going to get my calculator up, and the log button is kind of next to the 7 on your calculator face. So we would do log of 2, close the parenthesis, divide log 8, close the parenthesis, and enter, which it comes out to be a decimal 0.33333. And I hope you realize that that particular decimal is equivalent to 1/3. Okay, question 2 is similar to that. They want you to find log base 3 of 471,800 to 4 decimal places. Again, in this case, I want to use the change of base formula because my calculator won't do a base of 3. So again, in this format, I would have log base b of a. So b is 3 and a is the 471,800. So I plug that into the formula and I would have log of 471,800. You're going to have parentheses around that in the calculator, divided by log of 3. So again, I'm going to pull my calculator up. I would type log of 471,800, close the parentheses, divide log 3, close the parentheses, and enter. And it asks for 4 decimal places. So this is approximately 11.8916. Okay, so approximately 11.8916. So honestly, when you're asked to evaluate, you're going to use the calculator, but you do need that change of base formula. Question 3, you're asked to determine the inverse of the function f of x equals log base 5 of 7x plus 3. Now remember that f of x is the same as y, and our first step in finding the inverse of any function is to interchange x and y. So this will become x equals log base 5 of 7y plus 3. And then my goal there is to solve for y. So the first thing I'm going to do is I need to eliminate the log. I'm going to do that by raising both sides to the fifth power. So I'm going to do 5 to the x equals 5 log base 5 of 7y plus 3. So that gives me 5 to the x equals exponential base 5, log base 5, cancel each other off, and I have 7y plus 3. Again, keeping in mind I'm trying to solve for y, I'm then going to subtract 3 from either side. So I have 5 to the x minus 3 equals 7y. And then I need to divide by 7 for the entire problem. So I end up with 5 to the x minus 3, all divided by 7, which represents y. But in this scenario, that y that we just solved for is our f inverse. So 5 to the x minus 3, all divided by 7, would be the inverse of log base 5 of 7x plus 3. All right, one more. Number 4 says solve the logarithmic equation log base 3 of x equals 2 plus log base 3 of 2x minus 3. Now, one of the things I notice in this problem is that initially the logs are on opposite sides of the equal sign. So the first thing I need to do is to get the logs together on the same side. So I'm going to do minus log base 3 of 2x minus 3 on either side so that I have log base 3 of x minus log base 3 of 2x minus 3, and that's going to be equal to 2, so that I've got the two logs together on the left-hand side. Then I'm going to use the properties of logarithms, and I have a subtraction problem. Subtraction is rewritten as division, so we have log base 3 of x divided by 2x minus 3, and that's equal to 2. Then I want to eliminate the log base 3, and I do that by raising each side to a base of 3. So I would have 3 to log 3 of x over 2x minus 3 equals 3 to the second power. Okay, so when I do that, then remembering that the exponential and the logarithmic are inverses of each other, so base 3 and log base 3 will divide out or cancel, so I have x over 2x minus 3 equals 3 squared, which is 9. I'm going to put that over 1 to make it a fraction so that I have a fraction equal to a fraction, and I'm going to solve it by cross multiplication. So 1 times x is x, and then 9 times 2x minus 3. And we're going to work that problem out. So distribute the 9. Okay, so I would have x equals 18x minus 27. I'm going to subtract 18x from either side to get all of the x's together. Whoops, excuse me. So that gives me negative 17x equals negative 27. I'm then going to divide both sides by negative 17. So x equals 27 over 17, and it turns out to be positive because a negative divided by a negative is a positive. And so there would be your answer to that particular problem. And I don't think they ask you to round it to, nope, they just ask you to solve it. So 27 over 17. We'll pick up this review in next video.